Yeah.
Hello, everybody, and thank you very much for joining me today. It's Allan Laboucan with the Rocks and Stocks News show. We've got another of our interviews with executives of junior mining companies, and today's guest is 9 Mile Metal, sorry. And they trade on the Canadian Stock Exchange under the symbol NINE. They burst onto my radar screen a few months ago when they announced the discovery of a thick lens of extreme high-grade copper. And I'm a big fan of copper with the revolution happening in the automobile industry and my long-time experience in this industry, that there just isn't enough junior mining companies or exploration and mine development for that matter in copper. And I think these guys have something very special. So I invited them to be a sponsor of my website shows, and they were kind enough to take me up on that. So I plan on doing a lot of interviews. Patrick Cruikshank and Gary Lohman are here to join us and talk about 9 Mile Metals. Thank you very much for joining me today, guys.
Well, thanks for inviting us, Allan. We're happy to be here and share our story.
So the start of the story for me was that thick lens of high-grade copper. And why don't you guys start by talking about that?
Yeah, we've been in the Bathurst mining camp now for 5 years, building our projects, and we're very excited about the 9 Mile Brook project. We have 3 projects in Nine. We have 9 Mile Brook, we have California Lake, and we have Canoe Landing Lake East and West, and they're all VMS projects. But you're very correct. Our lens that we have on 9 Mile Brook is the highest grade assay VMS lens reported in the Bathurst camp. And I don't know if you're familiar, but the Bathurst camp has 95 occurrences and 45 deposits of VMS. It's world famous, 3rd largest mining camp on the planet. The famous Brunswick number 12 mine and the number 6, and the recently Caribou for Trevally producing. It's a world-class VMS camp, but you're very accurate. Our lens assays are phenomenal. With copper, lead, zinc, silver, and gold, our lens is averaging just around 10% copper, which is phenomenal. You know, and our lead zinc is 20% plus, and our silver's 200 to 400 grams, and we're 1.5 to 3 grams gold. So it's very high grade across the board. The average in the camp is usually 0.5% copper, 12% lead zinc, about 100 grams silver, and about 0.5 gram to 1 gram of gold. Even the famous, and so a lot of them, even the Caribou, they only process the lead, zinc, and silver. So, the largest gold deposit in Bathurst is a tailings pile from the Caribou mine. But we are very, very excited. As you know, the way these deposits are formed, and they're broken up into a pearl chain or a series of broken lenses with all the folding, and Gary's actually the one discussing the geology and the formation. But why we're very excited is we have the California Lake Formation, which is the actual 470 million year old rock formation that hosts the predominant deposits. That is the volcano time rock. So that goes right through 9 Mile Brook and California and Canoe. So we're very excited there. And usually it's the contacts and the overlapping and the folding that creates these deposits. So anyway, the lens is phenomenal. It's never by itself. It's not far from the source. It could be a series of lenses, like the Trevally Caribou mine is 6 lenses. They found the first one, and then they'll find the second, the third, and they're all broken up, and they're all when you put them all together, you have the original deposit. But we have some very interesting geology around our lens. And so we've had the government on site. We did our drill program, and we've publish those assays, lab certified. And we do have, you know, the structural geologist, PhD, and everything from the government, and they are very, very firm. And they've talked about this recently, that they only believe 30% of the deposits have been found. Right? Every 20 years, there's a new technology that comes that's groundbreaking, and you have a rash of discoveries. You know, whether it's gravity in the 50s or VTEM in the 80s. Well, now it's drone and reprocessing, 3D and AI. You know, we have enough material and data now to actually have machine learning AI work very nicely. When you have 95 discoveries, you know, and you have 3,000 soils and different rock formations and age rock, and it's very easy to create these rules when you have a folded nose and you have a hinge on that nose and it's within 400 meters of a lens.
Yeah.
And you have parallel folds in the structure. We've proved the structure broke the lens, right? It's a hard break between 11 meters and 19 meters. It goes from 10% to 0 into the sediments. We know it's a hard break. It's not bleeding into the sediments. We know that we have copper stringers, and then we have the sericite and the black chlorite. And that's proof of the feeder system to this lens by the government. This is the, you know, you may call it the vent, you may call it the pipe, but it is the feeder system. And you know, there's just no mineralization there anymore. When it finishes, it collapses and it's empty. But that is the feeder system, and it all points to the hinge A on our target screen.
Well, I did a fair bit of homework after seeing your initial results because I wanted to find out about the area. There was some very good papers out there that I read. Then I honed in on your project, and I saw a distinct rock package there with, as you said, a hinge. And then you put the geophysics out, and it looks like there's a series of geophysical anomalies in that rock package. And, you know, where the hinge is often where the rock is well prepared for those fluids to make their way up to the surface. And then in between that hinge and your lens, there's a nice geophysical anomaly there as well that kind of stands out to me as a potential for a magma chamber. And the whole system could be, the plumbing could be at that hinge. What do you think about my analysis of it, Gary?
I like with the hinge, that's like you say, a beautiful spot for mineralization, not only preparation for fluids, but even after deposition. Like here, we've got a lot of folding that helps concentrate the mineralization, because the massive sulphides is they mobilize like a plastic flow. They don't break up that much, so that adds an ideal target.
And what about that geophysical anomaly that sort of sits in between the hinge? And yeah, you can see it right there. So
there's our lens, Allan.
Yeah,
This is our lens.
And then in between the hinge and the lens is a bullseye target to me. I spent a good part of my career in diamond exploration, Gary, and that looks like something that is quite interesting there. Your hand was just on it.
Yeah, that's the lens right there, Allan.
Yeah,
And
now go a little to the south and a little, or go to the east and a little south, and you see that geophysical anomaly that stands out like a sword.
Yeah, so this is your folded nose right here.
Right.
This is your hinge.
Right.
Now, this is actually bigger. This green is part of this, and it plunges. That's why it's faded. We have another folded nose here with a hinge plunging again. So
those are your prime targets, your A and B, I believe you cut.
Hinge A, hinge B, and you know, even the Brunswick 12 had 6 folds and a hinge, right? So there is a an argument. And but again, if this is our lens, you've got, and this is from our drone, for 1,000 line kilometer high definition drone survey. And what this, I want to show you another image and show you the value of.
Before you switch screens, that stuff that's going almost directly north, all those geophysical anomalies look like they could be VMS targets to me as well.
What, on here?
Yes, all of
No,
those.
it would, well, don't forget, your VMS deposits are normally on the halo.
Right?
This is really, if you want to call it layman terms, an iron X-ray, right?
Okay.
So we're looking for the nodes on the sides. That's the
Right.
mineralization. The pimples, the nodes, not the actual magnetic trend here. It's
Right.
it's where it gets puked out. Is not a great technical word, but it's effective, right? So not the actual trend, but this node to the side. And I can show you the Brunswick 12 image. I can show you, look, and we're very excited about this. We call them the Hawaiian Islands right here. That is a
Right.
southern contact of the California formation. Here's the northern contact here. And the government's very excited about this target 5 that we have, but it's not the source of the lens.
Okay.
So we've got to keep, this program is going to be testing hinge A, hinge B, and there's actually some other iron formation.
Well,
down there.
that's what got me so excited about the anomaly at that hinge area, is because you hit a thick intersection of extreme high grade. And, that likely came from a very close proximity, is my guess.
Yeah,
Yeah.
the lens does not travel far. And if you go back, I'll share my screen again, and but I want to share my whole desktop. So let's see. This is what we work from prior. Okay.
Okay.
This is the area. There's the lens right there.
Yeah.
Okay. Now look what we get from the reprocessing.
Wow, what a difference.
Right? That's the that's the what we had. And that's what everyone's been working from. And then you go, right? And look at the difference in those two mag
Yeah.
images.
Because the one on
This
the
is what
right,
EarthEX has done, and you see the parallels here. Of the
yes,
folding, and all up here. So EarthX has told us there's at least 6 folds. Look at it like a reverse L.
yeah,
And then this is another one. And
Yeah.
then this is one. And this is one. And this is one. So very similar to what we're getting with
the thing that I noticed between your processed and your unprocessed, if you will, is
Yeah.
the stuff on the right is quite noisy.
well,
And
that's yeah. And look at it. It looks like the Rocky Mountain range, whereas on the other image where it's filtered and with the drone, you've got it identified and defined.
much better, that's
And
for sure.
and that's what they're doing, is they're tweaking the drone frequency, right? To
Mhm.
look for the conductive materials. So you're filtering a lot of the noise out, and it's pretty incredible.
So-
because this is done 200, 400 meter spacing from helicopters, and it's just, that's where the technology is taking us. It's phenomenal. And you can even see it better in some of our other images. See, there's your
Yeah, there you go.
extension, and it plunges down roughly the same as the Brunswick 12. This has
Wow.
your target with a plunging body. It's very similar to what and this is the Brunswick.
Actually, that image on the left looks like, to me, you've got a hinge and then almost like 2 hinges converging right beside that lens.
Where's
Yeah.
a second hinge?
Well, you've
See,
got,
the difference is there's the lens there, Allan. So this is about,
okay, what I mean is, okay, so take a look at what goes north to south,
yeah,
and then it hinges. But if you look at your target B and you go from west over to the east and then up, it's like, it looks like a double hinge there.
Well, we're saying, you could argue two things. This is a folded nose, and there's your hinge. This is a separate folded nose with a hinge. Or you could argue this is a fold.
Yes.
This is a parallel fold.
Yeah, that's what I'm talking
and we
about.
start going across. But either way, the government and our technical team, this is definitely a hinge. This is an extension that plunges deeper, because don't forget, 60 to 80 degrees are these deposits. This is the same here. And you can see these little pimples might be additional lenses, but this is the Brunswick 12 on the right.
Oh, wow.
Right? So, yeah.
So you've got that same
It's always it's the hinge or it's always on the halo of the formation, and it's not in the middle of the trend. It's not the middle of the trend.
I'm tremendously excited about the lens and looking for the source and the potential to find multiple VMS bodies there. But you recently announced your California lake is where you're going to start drilling. So I did some homework on there, and I looked at Google Earth and I saw some interesting structures. And then I looked at your geophysics, and it looks like there's a chain of pearls there that are quite interesting. Can you speak to that for us, Gary?
I'll just finish up real quick here on a regional standpoint, because all three projects are in this saddle of the camp, right? So we're very proud of the quality of our three projects. This is 9 Mile Brook.
Yes.
Here's the lens.
Yes.
There's your structure and
Yes.
your fold, right?
Yes.
Here's your other one. This orange path, this fairway, is your Spruce Lake. That is your 470 million year old rock.
And that Spruce Lake is all the hits, all the mines along to the west of you.
Yeah, I'll show you that next on the regional. But this is, remember the Hawaiian Islands I showed you? It's on this contact.
Right at the
other contact is up here.
Wow.
And then you've got but you can see all your folds with the geology.
And if my memory serves me correctly, all along that package of rock, the deposits are at the contacts.
Yes. And I'm going to show you the camp.
There you go.
That's the camp.
Yeah.
Okay. So the orange are all the big deposits.
Caribou's on the southern contact, McMaster's on the northern, Orvan,
Rocky Brook is 20 million tons, Restigouche, and there's been no work here. Wow. The California Landing Lake deposit's 22 million tons, but it is the only deposit that's not native in place. It came from 10 kilometers away, and it's weathered, and that's why it's such low grade. It was transported into this synform here. Okay. But out of this whole, we call it the saddle. So we've got highly perspective, obviously, here, but that's a different system than the lens.
Right.
The lens, we believe, is sourced down here, but we have high quality targets along this, and it gets pinched out. You can see this is the original Canoe Landing Lake West. I'll bring up.
Well, those hinges and those pinches are very good rock preparation, right, Gary?
Yeah.
Pressure's a good thing, right?
Absolutely.
I'm going to bring up.
It makes diamonds, and hopefully it makes for copper deposits in New Brunswick.
Yeah, this is California Lake right here. So again, here's the formation coming down, right?
Yeah, actually, you could, I did some Google Earth. One of my favorite tools for exploration is Google Earth. And you can, at California Lake, there's another lake to the north and east of it. And then it looks like there's a structure that goes off of that second lake. Am I seeing that correctly, Gary?
So this is California Lake here.
Yeah,
This is Canoe West, Canoe East, and 9 miles over here.
okay.
There's Canoe Landing Lake Deposit. And you can see it's got a red line. That's a strong conductive response.
But you're
The red-
starting your drilling where?
The red, okay, so this is EarthEX. This is their reprocessed Megatem government data. And then they go into the data and look for the strong conductors for the VMS signature, right?
Right.
And that's what the red is. Well, if you see this, this is Canoe East. We believe this also goes under our property, by the way. We could drill that. And here's Canoe. But this California Lake here, there's two very big systems. Obviously, the continuation of the strong conductor comes up here, and we are drilling here.
You see that string of pearls I'm talking about, Gary?
Yeah.
Well, that again, this whole string, we want the nodes, right? The nodes are the targets. So you could argue all this trend, these are all, and look at the strong conductor. It correlates to the strong conductive response of the
And
magnetics.
in
We also-
reality, you
We
don't.
also like this, Allan. This is very high priority, this V trend.
I see that.
But
And
obviously, that'll be round 2. But we have, this will fly with the drone, right? So, but we're definitely going to drill this because it continues in, and like this whole saddle is so
perspective.
perspective
Gary,
for us and the government, who say there's 70% deposits still out there, but no one's done the work here because it's a little bit more complex. There's folding. It's, you know, until this new technology, they've spent a lot of money drilling blind, and 80 meters, you're not going to find VMS at 80 meters, right? It's typically 300 to 400 meter pay zone. But this technology is groundbreaking. The AI is groundbreaking. The reprocessing algorithms, the way that Daniel did all this prior to the drone, and it correlates exactly. So the proof of concept and process works. But
all of
this
those,
is
all
this
those,
is
all those squares belong to you, the dark squares, or?
yeah. So here are the claim lines. This is California Lake here.
Yeah.
These heavy black borders here is Canoe West. This is Canoe East, and this is 9 Mile. So they're all over the very high priority Orange California Lake Formation, the 470-million-year-old rock, which hosted the volcanic activity.
And
So-
what also makes California Lake quite exciting is you've got 2 showings there in yellow.
Yeah.
And right beside the one, well, both of them you could argue but right beside the one to the west, you've got that string of pearls of geophysical anomalies.
And, you know, just because this is yellow, it's a medium conductor. That doesn't mean there's no deposit, right? Not all
Absolutely.
deposits are on the red strong conductors. There's there's graphite, there's other things magnetic, right?
Yep.
Hematite and stuff like. But yeah, we know there's mineralization here. But again, no one's tested it deeper.
Wow.
No one's used the technology, and you know, we give you 1,000 examples of people that drilled, and it was 200 meters from the deposit. But you know,
And
third company
Gary-
found it, right?
Gary, it's not necessary that you have to have a hinge. Where you have a bend in the rock is a good spot as well, and it looks like you've got kind of a nice one there at California Lake. It's kind of right in the middle of a bend in the rocks, or in the anomaly.
That's correct. And
Are you talking here, Allan?
Yeah, actually on the other side of it.
On this
yes,
side?
Yes,
Between this trend and that trend?
yes, exactly. Well,
But again, remember Southern Contact.
yes,
So
and that's right
we
at the
have lots of targets. We have lots of targets there, lots of fun, lots of targets. But yeah, this is you know, you can see the whole trend, right?
Yes,
The
yes,
conductance.
absolutely.
And actually Canoe sits between 2 ridges, right? It's right
Okay.
between, just like these are between.
And that's but that's on the outside of the dark claim block. Is that part of yours as well?
No, so this is this is the Canoe Landing Lake deposit. This is our claim block.
Okay, gotcha.
So we Canoe East, Canoe West, and there's the deposit. Now, we
Oh,
believe it
gotcha.
goes under our property as well, but this isn't native. So all this other is native, right? So you almost pretend it's not there
Okay.
because it's low grade and weathered because it's moved and stretched over 2 kilometers when it moved, and it's weathered out, but it's not native. Whereas
Patrick, for an
look at
MBA,
this.
for an MBA, you got a pretty good understanding of the geology.
Yeah.
it's osmosis. He
He
doesn't talk about hockey or anything. He talks about geology and rocks, even in his sleep. So it's
Good.
anyway. But yeah,
So-
this is very perspective here, and we believe this continues under, right? So because it plunges, and we've had many meetings with the technical team at the government and so on. But yeah, this is very perspective.
You
through
know,
this
sometimes those in diamond exploration, it's sometimes those subtle geophysical anomalies are the ones that you really want to be targeting. Is that the same thing with this base metals, Gary?
Yeah, some of these are, and I think Patrick showed you an example of like the Brunswick. It's usually these little nodes or there's little bumps. The long, like the really long targets are maybe something stratigraphic, but it's short, 400 or 500 meters with a little offset or something. That's where they, like had some structural preparation and things have mobilized.
There's a lot of people that say, "Oh, I have this 2 kilometer long mag target."
Right.
Well, that is not going to be VMS, right?
Probably
there may be a
magnetite.
couple nodes on the halo, but that's the actual 2 kilometer body, because I think in our release we explained our lens. I'll bring it back up. Back to 9 miles, a really good example. I want to explain the footprint at surface. So just bring it back up. I almost closed our interview by mistake.
Hey, don't do that.
I know.
We'll take your
There we
MBA
go.
away from you.
So this surface footprint.
You're not
is-
share screen.
Where are you? Okay, share screen.
Don't end the meeting. You got more to talk about, Patrick.
Unfortunately, I'm just starting, right?
Isn't
All right, so let me share
that
this.
the nature, hey Gary, when you throw I had a geologist mentor, and he said to me one time that, when you're looking at an area, oftentimes there's big arm waving. And when you start to drill, everything gets smaller. But when you throw a lot of science at a mine, as you drill, it gets bigger. And you guys are looking that way to me.
Well, this is, and I really found the drone work exceptionally useful. This area has been looked at in the past, and there's a lot of detailed geology. And I'm familiar with some of the gentlemen that did the work, and you can see where maybe they've sketched some things in, or looking at, using maybe crude magnetics to extend the units. And this has provided a lot more detail, and some things are appearing cross-cutting now and not as they were previously known.
Now,
That goes back to Patrick's point, where sort of that every 10, 20 years, it's an innovation in processing or, system work that's bringing out the detail.
Because when you see that old mag image, Allan, when you
hold-
see the old mag image, it's so busy and wide.
yeah,
No one's
noisy.
ever seen this, but when you see this, there's even a hinge here.
Yeah.
So
Now, Gary,
like where I was going, this footprint's about 500 meters, and that is the classic VMS deposit footprint at surface, because these are vertical deposits. So the footprint at the surface is about 500 meters. Anything bigger, it's probably something else, because it's vertical. This plunges almost a kilometer, like the Brunswick 12, right?
Gary, you brought up an interesting point there, and I think I'd like to, for the non-geologist out there, the importance of this drone is oftentimes when you're doing geophysics, you're quite a bit above the ground level. With these drones, you can get right on top of the ground, which gives you better resolution. Is that correct, Gary?
Yes, they've actually, the one that they're using has collision avoidance, so they can go pretty much a treetop.
Wow.
Yeah, it's 10
The
10 feet above treetop. It's got built 5 GPSs. It has LiDAR built in, anti-collision. So when there is a clearing, it drops. Like they've done in northern Manitoba.
And that allows you to get better resolution on your geophysics, right, Gary?
Well, the magnetometer will go down about almost a kilometer anyway.
I'll say they can model it down to that.
Yeah.
Okay.
It's an exceptional amount of data. And the other thing is performance. When I started as a young geologist, if I could get a kilometer a day on the ground, I was doing good. And these guys can fly over 100 kilometers a day.
Wow.
Yeah. So
Wow.
back to your point, compare it to VTEM. So you got a helicopter at 4,000 feet, right? With hula
Yes.
hoops doing 200-meter spacing and
Yeah.
extrapolating the data points. Now you got a drone that flies 100 feet off the ground that has high definition. It'll go down, 4, 5, 6, whatever it is, 25-meter spacing and it's a continuous data point. So you're not extrapolating your data points and averaging and so on, but you can look at the resolution right there on your screen. Compare.
Yeah, no, it's tremendous compared to the noise from the.
You wouldn't, and the other thing Gary said is these 2 hinges, A, B, C, like this, all this has created brand new targets that have never ever been drilled. These are actually more into the woods, not in the clearing, and no one's drilled. And these are going to be deeper. These are deeper than 50-meter holes.
As you've been showing this image, something's kind of standing out to me there is that if you follow that mag low, I think it's mag, and right about the middle of your spikes on there seems to be a break there. Is that a fault of some sort, Gary?
Where are you, Allan?
Right in between your A and C target. In the middle of it, almost at the
That could be a
bottom of the
fault.
seat.
Yeah, you could probably get an offsetting fault in there.
Okay.
Yeah. And also the deep blue, that'll be also related to some processing where you've got a real steep gradient with something exceptionally high magnetic and something low beside it.
Right.
But that does provide you good resolution.
Well, I think it's pretty clear from what we've talked about today that you guys have a substantial amount of targets to go after here in a camp that has a substantial amount of mines in it. And knowing what we know about VMS deposits, they occur in clusters. So, it's quite apparent that you have the potential to find lots of good stuff here. Patrick, can we talk a little bit about where you are now with your drilling, what the plans are going forward from today forward for the audience?
Sure. So we've got all our permits. We've had all the forestry and the Department of Energy and Mines for drilling, water, etc. That's all done. We've got a rig mobilizing on Tuesday for California Lake. So the plan is to have California, it's a smaller program, right? So we'll have California Lake drilling because that rig doesn't have to be as deep. So we've got a rig arriving there and then we have a second rig coming for 9 Mile. And when California is finished, it'll join up. We'll have 2 rigs at 9 Mile drilling. But we're still going to do our geophysics. So we're going to plan on drilling a hinge with a deeper hole, drill this hinge with a deep hole, do our downhole borehole EM right there and then first. It'll be processed within 24 hours. And we should get a picture of this extended body and this extended body and anything within. So if we drill 500 meters, you usually get a 500 meter in all directions. So that should give us some definition, and it'll be integrated immediately for the step out drill program.
I think you guys
We
are
do
gonna
have some
make,
target lenses, but obviously the systems are the main targets. And even we're if we have some meters left, we're going to target number 5 up there, because there is rhyolite. It has its own support for a target and a system, and being part of that California Spruce Lake formation.
well, it all seems to
Contacts,
be,
it's a grade A target too.
all
completely
seems to be a
separate.
pattern there, eh, Gary?
Yeah.
Uh,
That's, like the Hawaiian Islands, that's neatly along the contact.
yeah,
And some of those little mag highs are, even when I relate to some of the old geology, you can see what's causing them.
yeah,
And getting some interfingering of volcanics.
wow. So I think you guys are gonna make me look really smart, because when I saw the lens, I immediately did my homework and saw the structural hinge just to the east of it.
Yeah.
And that was my initial guess of where you could be looking.
We're going to call that Allan's hinge.
Ah!
Hinge A, Hinge Allan, right? Like that's Allan's hinge. You've been saying it for a while. We just need to back it up with the science. But, there's even like another potential lens there. But again, back to the metrics, 500 meters, downward plunge, 17 degrees, whatever it is, just like the Brunswick. This distance is 3 to 500 meters. So our borehole didn't pick it up, but the borehole did pick up a mass to the east because it was only 200 meters down.
Right.
This one is right here is about 700 meters to 1,000 meters. So, you got 2 potential sources. We believe Hinge A is obviously that lenses, but we got a very good chance of 2 separate issues here.
Well,
And a
now,
third up in the northwest, which is completely unrelated, but the camp is the camp, right? And you've seen all this parallel folds.
yeah,
just going
wow,
across.
Yeah,
It's very, very
tremendous.
exciting for
tremendous.
geologists.
I don't blame them. It stands out like a sore thumb to me as well.
Yeah. So we
Um,
hopefully to make you into a guru with a good
Oh
result
my gosh,
on the Allan hinge.
not again. Gary, what this brings up to me is that, you could be looking at a cluster here that has some big size. Like you start looking at the Iberian Pyrite Belt, and those VMS bodies are, 100 million tons plus. And do you think there's size that these things could get sizable as well?
Well, that's one thing. Even the geologist with the Department of Mines mentioned the Brunswick 12 was like the 3rd largest zinc mine in the world. Like it's a super giant, and he believes that's not the only one here.
Wow.
There's a bigger one in the camp still to be discovered.
Yeah.
But it's complex. It's upside down. It's folded. It's inverted. It's, they're broken up with all the extreme folding. And you saw that saddle in the camp. There's so much pressure points, and it's deep, and that's okay. That's okay. But,
That's good. That's great, actually. That's what you want.
335 million tons. It produced 133 million tons of output production.
Yeah.
Wow.
Like what would that mine be today? It mined for 50 something years. It just stopped in 2013, I believe.
Yeah.
And it didn't stop because it ran out of ore. It stopped because it was almost 1.5 miles deep and so unsafe and unstable because it,
Well, and it gets me back to the start. That grade and that thickness of a lens,
that is unique to the camp, period.
It's tremendous. Well, it tells me that, the source of where that's coming from should be high grade as well.
Yeah.
And not very far away.
Yeah. They're never alone. So we know there's a string of pearls of the lenses, or there's a broken off lens from that nose, and that source deposits maybe more together, but it's not far, and it has to be so close to the vent and pipe that, even Jim Walker at the government says you can't get that grade unless it's like right there.
That grade and that thickness.
Yeah. Yeah, and it's a hard break. So we know with the lens 1, lens 2 should continue with the same grades. It's a hard break. And don't forget with you don't get copper and you don't get copper stringers unless you're over like 400 degrees Fahrenheit in the vent for copper to move, right? And we've got that extreme copper. Like there's nothing even close to that. Like a super gene in copper, like Trevali's Caribou, it had like a half, the highest grade it had was like 0.75% copper for like a meter.
That's
In a whole lens. Ours,
that's
the whole
another
darn.
thing that really stood out to me from doing my homework on the area was the difference in the grade.
But
It's
yeah, I mean, with
multiples.
this geology and the hinge and the nodes and all this, like the 20 boxes that have to be checked before you can really call it a high priority target, right? They're all there, and we were lucky enough to have a lens, and we proved it was bigger, and the grade, I'm just shocked no one's ever drilled it. I mean, no one did the work. And you probably hear this 1,000 times from different sponsors, that the 8th person thinking outside the box, not just new technology, but goes, well, why didn't anyone look at
That's
this?
a study that was done by Newmont. They did a study of deposits and mines all over the world, and oftentimes it was the 7th or 8th group that was in there. And I can say the same thing about the area that I live in Zacatecas, Mexico. The Fresnillo district is a series of veins, and then about 1,000 meters away, Mag Silver, that's been in production for 500 years. That cluster, they walked over. Geologists had to walk over, and it just happened to be blind veins that Mag Silver found that resulted in what will now be the 2nd lowest cost producer of silver on the planet.
Well, I hope we're another example for Newmont, because didn't they have this property at one point? And I'll give you a really good example. So a good friend of ours in Australia, Minotaur, Australia, who discovered Prominent Hill, right? IOCG, 1.2 billion, whatever, monsters, right? Elephants, copper, gold. When they discovered it, there were drill holes 300 meters away from previous companies. So Mother Nature's still pretty sticky, right? But this technology,
you guys are applying new technology and new methods to get better resolution, and you're finding stuff with the truth machine, and you're in elephant country in a place that's very mining, pro mining.
Yeah, and I was going to bring up, like when you mentioned Newmont, like Patrick said, they had this before, but we're going back to more old school. They did soils, they did trenching, and they drilled. And now it's not, you're getting a totally different look. At California Lake, the original hole in there was in 1956. And there's been a lot of work done in the 90s. And I've just in the last week on site, I found 2 concrete monuments with steel pins in them. That was somebody in the 1990s that put those in for reference points for future exploration.
Yeah. Wow.
Well, we can bring up the great thing about the Bathurst Mining Camp and the New Brunswick jurisdiction is everything's digital online. So we can pull up old assessment reports on any claim and any work done, any drill hole, any soils and stuff. And always, all of them always say round 2, follow up, do borehole EM, and then they disappear because they didn't have a strike on the first 10 holes at 80 meters. They move on to another project and never come back. And it took us 5 years to acquire all that property and in the right formations and the area where there's been no real any substance.
That's very evident in the work that you've presented today, that you're in the right package of rock. You're seeing the right things with the geophysics. I think you guys got something special here. I'm quite surprised that you know, the valuation of the company is only 13 million Canadian. You're in elephant country and you found something that's tremendously high grade and the source has to be close.
Yeah, and the grade is extreme, even in VMS in Newfoundland or even over in Portugal, and other VMS camps don't have the grade. But you know, we just got to find the second lens or the beginning of the string or a source deposit, and yeah, it won't be 13 million Canadian after that.
Well, I like the sounds of that. You guys have been really kind with your time. I think I'll let you have any closing arguments or closing statements, guys. I think we covered it all or a lot of it.
We covered some. It's I'll just go first, and we're very excited. We're here in Bathurst. We've got everything mobilizing this week. We feel very well prepared, almost over prepared. But we've got our crews here. We have our facilities, and we're excited. We've got a new corporate presentation finishing next couple of days. We just got a trove of EarthEX 3D and 2D data that every day we're getting stuff to update you. So hopefully you invite us back more often. We're redoing our website. We've got a Twitter. We will be sharing as much news because we will be working 7 days a week, 24 hours a day. The crews will be running 24 hours a day.
Patrick, you know the reason I've always prided myself on being able to recognize things very early. And the other thing that I really like about sponsors is that it allows me to keep telling the story as it evolves. So I think you guys are onto something special, and I think it's going to evolve into something tremendous. So thanks a lot for being a sponsor, and I'm certain we will be talking a lot doing these interviews, and I love doing that kind of stuff, Patrick.
Well, we'll be showing you some core in a couple of days.
Awesome. Well, and on a closing statement from me, talking to you two guys, you make a good team. Patrick, you're the CEO, and your enthusiasm for what's happening comes out clearly. And then in Gary, you've got the sound-minded scientist there with the nice grin on your face. I think you guys make a hell of a good combination.
Well, thank you. I think
Thank
we
you.
do. And hopefully it'll
Awesome.
show in our results, in our work.
Well, you've
But we have
already
a
shown
big,
that.
that being said, though, we have a phenomenal technical team with Daniel Card at EarthEX Solutions. He's doing stuff that no one else can do.
I can see that in the data.
Yeah, and we've got a phenomenal support system with the New Brunswick Department of Energy Mines and Jim Walker and John Langton, the minister, the mining register, and we can't say anything but incredible support from New Brunswick as jurisdiction, and the help and knowledge they've helped us, and they know their camp, and they, you know,
They want more mines.
It's a mining town. We've got really highly educated mining workforce. We have deep water ports. We are set up like all the boxes, and we can't wait to get round 2 going on 9 Mile and round 1 on California Lake. And
Well, you know, you guys have already shown something very exciting with the Truth Machine and drilling that lens, and now looking closer at your geophysics with the new processing methods and drones that can get closer to the surface and give you better resolution. Yeah, I think I'll close it off now because we could keep talking for hours.
Keep talking. Exactly. We'll save some topics for next time.
You got it. Okay, so there you go, folks. You know, when I'm looking at a project, you know, Patrick just mentioned ticking off the boxes. What they've ticked off so far is they've got the Truth Machine in there, and it's hit this extreme high-grade lens. The source of that lens, it's massive sulphides, so the source is probably very close. It looks like you go to the immediate east and you've got a beautiful hinge there that's just screaming to be drilled. And then they've got this California lake that is quite exciting as well. And then you go down the list of things you need to check off. Excellent geophysical work. They're in an elephant country camp. They've got a good access, and they've got a mining friendly jurisdiction. These guys are really ticking off all the important boxes, and I can't wait to see more data from their geophysical work and more data from their truth machine from California Lake, and then on to 9 Mile Brook. But when I take all of this into consideration, and then knowing that I can bring this to my audience with a $13 million valuation, that's a big check mark for me.
Yeah.
So as always, do your homework, speak with your financial advisors. My shows are for information purposes only. I invite you to do your homework, and as you do that homework, I think you'll be impressed with what these guys have. And on that note, have a great day, and we'll talk to you soon.